let's take a few minutes to talk about memory management in Java. In order to talk about memory management, we need to talk about the stack versus heap. We will also touch on pass by value versus pass by reference, as well as garbage collection. So let's talk about memory management in general. It's managed automatically by the JVM, that is the Java Virtual Machine. The stack and the heap are primary memory areas. And one thing you need to know is that there are many stacks, but there is only one heap. And that will become important. The garbage collector plays a role in cleaning up unused memory in the heap. Let's talk about stack memory. As I mentioned, you have more than one stack. And a stack is kind of what you think of when you think of a stack. It's a last in, first out kind of data structure, if you will. And this stack stores method calls and local variables. It stores the values of primitives and object references. They do not store the objects themselves. Because there are many stacks, they're thread safe and fast because having multiple stacks allows something called multi-threading and concurrency. And they're automatically released. Heap memory, on the other hand, stores our objects. So all the objects that we create are stored in the heap. There is only one heap, so this heap is shared across multiple threads and can be accessed by multiple threads. As a result, it's slower than the stack. And the heap memory is managed by the garbage collector. I'll talk more about that later. But essentially, what that means is that the garbage collector surveys the heap, and if there are any unused objects, it removes them. That's how it manages our memory. So here's a nice image of stack versus heap. And as you can see, our method calls are stored in the heap. References, so an object reference, so it's storing the reference which points to the string in the string pool, for example. Strings are objects in Java. It also has a reference pointing to the object. Okay. You also have your primitives in the stack. So your primitives are stored in the stack as well. And again, you have your reference pointing to the string, and you have the reference pointing to the object. Okay. And here's a nice little summary slide for comparison that you can look at your own time. We will briefly talk about pass by reference versus pass by value. As a matter of fact, I got asked this question on a job interview. What is the difference? So, in short, we'll start with pass by value. So pass by value is where you pass a copy of the value into a method. So if it's a primitive, you're taking the copy of the primitive value, passing it into the method. If it's an object, you're taking the object reference and passing it into the method. That's where pass by reference and pass by value come from. Java is always pass by value. As a matter of fact, most programming languages are pass by value. Okay. What changes is what is passed. Like I said, for a primitive, the copy of a value is passed. For an object, the object reference is passed. Okay, we're going to go through some code examples. But before we do, so we're going to go through some code examples. But before we do that, look at this picture. So let's go and take a look at our pass by value demo. So we have three methods. This increment method takes a primitive value, an integer, and increments it by 1. This rename method takes in a person and sets the name to Bob. So no matter what that person's object name is, it's going to end up being Bob, or so we think. Then reassign. So reassign, we're going to take this person, this reference, and we will try to reassign this reference by instantiating a new person named Charlie. So let's go through our run demo method, because this is how we're going to demonstrate that Java is a pass-by value language. So let's run this demo and see what we get. But before that, this is what we can expect to get. So before we call the increment method, the value of the number will be 5. Afterwards, the value of the number will still be 5. Okay? And this will demonstrate that Java is passed by value. Why? Because you're passing a copy of the value to the method. So modifications inside the methods do not affect the original variable. Here, you're instantiating a person named Alice. Before calling the rename method, the person's name is Alice. After calling the rename method, the person's name is Bob. Why? Because you pass object references into the method. You're not passing the object itself. And since you're passing the reference, the original object can be modified inside the method because you're acting on the reference. And one thing that's important in general is that in order to modify an object, you act on the reference. Now here, we're creating person 2, whose name is also Alice. And before reassigning person 2, their name is Alice. After reassigning person 2, their name is still Alice. Why? Because reassigning the parameter inside the method does not affect the original, since the copy of the reference is passed to the method. So again, you're passing a copy of the reference. So reassigning the parameter doesn't affect the original. Don't take my word for it. Let's just run this. Okay. Again, demonstrating what I just said. Before, the value was 5. After, the value was 5. So this shows that Java is passed by value. And I'm going to reiterate this. Modifications to primitives inside the methods do not affect the original variable, since a copy of the value is passed to the method. So you're affecting the copy, not the original variable. And then before rename, the name is Alice. After rename, the name is Bob. And since we're passing the value of the reference, you're modifying the object based on the value of the reference, based on the copy of the reference, which points to the original object. Before reassign, the name is Alice. After reassign, the name is still Alice. And this just shows that reassigning the parameter inside the method does not affect the original reference. And again, it's because the copy of the reference is passed to the method. The reference is passed, not the object itself. So there you have it. Now let's touch on garbage collection. So garbage collection automatically frees up memory. And essentially, garbage collection patrols the heap if it sees an object without a reference, i.e., the object is no longer in use. It removes the object from memory. The JVM controls when the garbage collector runs. That means we have no control over when the garbage collector runs. We can invoke the garbage collector through a system.gc command, but it's only a request. So as you can see here, we have these unused objects. We sweep them and we remove them. So why does it matter? It prevents memory leaks, improves performance, debugs any out-of-memory errors, and it's essential for scalable systems. So in summary, the stack contains our methods and primitives and references to any objects. The heap contains the objects themselves. Java is a pass-by-value language, and garbage collection is responsible for automatic memory cleanup. Thank you. Subscribe.